Ben Herzberg will be holding the lecture. Brace yourself, DDos is coming.
Thank you. Okay. You kind of spread all over the room, so that surely helps with my ADHD. So let's start. Start by saying that this is a part of a workshop, but because it was sort of a last-minute thing, it will be just an hour. So I'll try to squeeze in as much as we can. Hope it will be fun. We'll have some live demo, talk about DDos, and it will surely be fun. So first of all, let's start with me. I have 2 children, a boy and a girl. My career path was mainly offensive security and development. So that's that also hits what I like to do. And currently I'm the security research group manager for Imperva Incapsula, where we do DDoS mitigation, web application protection, and sophisticated automation attacks mitigation and such. So that's what I do. And there's also my social media skills, my social media links. So disclaimer, whatever I say or do is, this presentation is mine and not the company's. So if I say something, I don't know, I will try not to say something bad, but if I will, it's mine. And we also have a small game rule, because I was in the talk 2 days ago and I saw that there's a tradition with the Rakia thing that's here. So since this is a DDoS talk, excluding this slide, which I have to explain the rule, whenever I say amplification, okay, there's a shot for whoever wants from this Rakia, but I need a volunteer to do this. So who wants to volunteer? I need someone responsible. So come on, someone to help me out here. I need someone responsible. We can wait until the end of the talk, okay? No stress. Come on. Okay. You? Okay. Yes? The volunteer needs to handle the shot issue when I say, whenever I say amplification. That's, but he has to be responsible, and also not give it to under 18. So lots of responsibility. So here it is.
Okay.
If I say amplification outside of this slide, and I will. So
if you say
anyone wants,
I take a shot or what?
No, you give a shot to whoever wants.
To whoever.
Yeah. Tough game. Okay, you don't need to stand there. You can sit. It's okay.
No, I'm gonna stand.
Okay, you can stand as well. Okay, so let's start with the actual talk. So let's start with DDoS attacks, because I'm sure that many of you are familiar with the attacks, but let's do a small intro just in case. So what's a DDoS attack? A DDoS attack is any attack that is aimed at disrupting or denying service, any type of service. There are 2 terms, DDoS and DOS attacks. The difference is the extra D in the beginning, which means distributed. So any DOS attack is basically an attack that is aimed at disrupting service, right? A DDoS attack is distributed, meaning that we are running it through a lot of parallel machines. And the idea is first to leverage ourselves. So if I have 1 megabit and I'm using 100 other machines who has 1 megabit, I have now 100 megabit or gigabit. So that's the first thing, and it's another layer of separation between the attacker and the victims, as we will soon see. But the terms are used interchangeably today. So today, mostly when it's referred to, it's DDoS attacks. Okay? So let's make another distinction between volumetric attacks and application layer attacks. Volumetric attacks are attacks that are aimed at sending a lot of traffic Well, usually it's either a lot of traffic or a lot of packets, a lot of small packets to the victim. Usually this is established using reflective amplification techniques. Okay? I needed someone responsible. Okay. So, no. You go ahead. Okay, so usually that technique that I was speaking about, I don't want people to get drunk in the beginning. So basically this technique, reflective, is basically sending a command, sending packets to a service, usually over UDP, where what's missing in UDP contradicted to TCP. Yeah, the triple handshake. So in UDP, I can say I'm the source and give a fake IP address, and then I'm asking a question, getting getting more data from the server that I'm querying, and that data is not sent to me, it's sent to the victim. And we will see that soon. We will also run a small test to see how it looks like network-wise. So this is how basically it looks like in our systems. To the left, you can see a bandwidth-based volumetric attack. So we have around 300 gigabit of traffic going through to the victim. The peak, the top that we have seen so far is 470 gigabit per second. And to the right, you see an attack that's based at high mega packets per second, meaning that we're sending smaller packets, but we're sending a lot of packets. Now, what's the idea behind this thing? Basically, since we need to deny the service, we don't really care how. So one of the ways is to exhaust the bandwidth of our victim. And another way is to send so many packets that the controls, like the edge router and the firewall, will not be able to take care of. And then we also have denial of service. Opposed to volumetric attacks, layer 7 attacks or application layer attacks are attacks that are done not by spoofing addresses or sending a lot of packets, but by causing operations that are expensive to the victim, and we are sending them. For example, if I have a price comparison website, and the price comparison website, I don't know how many of you deal with database design, but usually when you have such a website, you would try to index it properly, because lots of people will try to get the product sorted by the lowest price, right? Or the highest rating. So if I'm an attacker, I will do the opposite. I will try to get to probably content that's not cacheable, and content that's page 29 sorted by, I don't know, company size or something like that. Doing whatever I can so that each request to the database would take more effort. And sending enough of these can disrupt the service because the database server will not function, or the web server will not function. So the layer 7 attacks can also be logical. For example, if I have a bank account, if I have a bank, and I don't have a bank, but if I had a bank, and if the forgot password mechanism would, when I'm placing an email, let's say, it blocks this account until it resets the password, sends the new password by mail with the token link. It sends the activation link to the client. But then it blocks the account infinitely. If I can enumerate all the email addresses of the bank clients, I can deny service in a logical way by simply resetting all the passwords of all the clients. So that's another type. Now there's something in the middle between volumetric attack and layer 7 attacks that volumetric layer 7 attacks, basically it's sending a lot of HTTP requests, so it means that we're completing the three-way handshake, sending, let's say, post requests, just sending them volumetrically, sending tons of them, usually using a botnet. So that's how those attacks look like. So we see in proportionate amount of traffic being sent to a website. We're seeing tons of requests sent to the website, and those are all the attack. You can see in the bottom, you almost can't see it. That's the legitimate traffic because the attack is so much stronger. So that's how it looks like when a website is being attacked using an application layer volumetric attack. What we do about these type of attacks, we fingerprint clients according to certain layers of fingerprinting to find out what's a bot and what's not when they're initiating the connection. So anyways, before we go further, just two more statistics, okay? So we make this quarterly report, like every research group makes some sort of quarterly report. So we make a quarterly DDoS report, and in the last one, almost 25% of the attacks were multi-vector at once. So and this keeps going higher, and attackers are of course getting more sophisticated. For example, they're using JavaScript supported clients in order to bypass some of the DDoS mitigation tools. They're they're supporting cookies. They're doing a lot of things to still get an advantage in this DDoS game, and these percentages keeps going higher, of course. And second thing is that we've seen that sites are getting attacked, even though the sites we have statistics for are sites which are protected. So even though the attacks fail, we see that more and more sites are getting re-attacked. The reason to that, I will not go in depth about that because I deleted it from the presentation because we don't have a lot of time, is the DDoS economy, which it's very cheap to issue DDoS attacks. Just today, two Israeli guys from my country were arrested for running a DDoS booter called VDOS. They were arrested today, but they were operating for 2 years, and they earned over $600,000 revenue for doing the DDoS attacks. So they had some pocket money for it, and usually these types of attacks cost anywhere between $5 and $30 per month for, let's say, for about an hour of attack, which is enough to cause considerable damage. So why? Why would anyone want to do this? I mean, I can understand why I want to do a SQL injection to get credit cards so I can buy stuff. I can understand why I want to do SQL injection attacks in order to get information which I can trade with. I can understand why I want remote code execution over a machine because of reasons. And I can understand why I want stored XSS. Why would I want to do to run a DDoS campaign? And this is a question for you guys. Anyone has a reason why?
Amplification.
Sure. But I didn't say amplification. Oh, okay, now I did.
I didn't say that.
But you should. Okay, who said that? Extortion. Extortion is a good reason. Okay. What other reasons? Let's see if we
taking out the competition.
Oh, hi.
Taking out the competition.
Taking out the competition.
Competitor sites.
Yeah, taking out the competition is good. What else? Ransom, extortion. Okay. Yeah? Two? Okay, you hate, you have something, just some bad feelings about their company. Yeah, this person get on your nerves. I can understand that reason.
If you have too much time.
You have too much time, right? You're bored, you have too much time, like.
Or for fun.
Or for fun. Okay, anyone else? More reasons? Okay, I think we probably summed it up pretty good. So let's see what I wrote and see how close we are. So Rivalry, I think we mentioned this, right? Business Rivalry. I have a shop. It sells instruments. Someone else sells instruments. I want to sell more, so I just knock their site off. It costs. It doesn't cost a lot, and people will buy from me. Again, the costs are very low. Then there's extortion. You send an email, an anonymized email with a Bitcoin, and before you know it, you have some cash in your pockets because basically what you're saying is, pay me now. Usually it's the average we see is about 15 Bitcoins. So it's, let's say, a reasonable amount for an organization to pay. And if you don't pay me, once I attack, you will have to pay me 25, and then each day 10 more. Now the attackers are also, they're saying, I'm from X, for example, from Armada Collective. Now, since this is anonymized, the person who is sending it is either affiliated with that organization or not, but you're getting the extortion anyway if someone pays. And again, you only need to either do nothing before you send these extortion letters, or you need to do a short 10-minute, 20-minute DDoS attack saying, hey, I knocked your services off, now if you don't pay me, I can do it for a full day. So this is one of the leading reasons. There's hacktivists performing attacks. So for many different reasons, they can be really many different reasons. As long as it's trendy, you're getting even volunteers to help you set up the botnet, even people who volunteer to participate, to be part of that botnet. Then we didn't mention state-sponsored or cyber terrorism. Allegedly, Russia disconnected Estonia from the internet a couple of years ago. Now, the great thing about it, in terms of course, the attacker, is if let's say Israel now sends striker bombers to bomb Iran, or vice versa, it will start a war. But when you're doing something like this, you can create a lot of damage. However, you're not really starting a war, so it's something that states can play with. And of course, in terms of defense budgets, it's peanuts. It's like the spring water they serve for meetings. It's nothing for them. So state-sponsored is also a reason. / cyber terrorism nowadays. Some of the terrorist organizations has funds of states, so it's more or less the same, like ISIS and such. Then we said if you just don't like that person, you don't like that company, so that's also a good reason why people do DDoS attacks. And then there's another reason. Supposedly the latest attack in Australia was a smokescreen attack. Meaning that there's a DDoS attack, everybody runs to the monitors, wants to get their network back up, and then a small attack, a breach happens, or any sort of more concealed attack happens. Now, this is one type of smoke screen. The other type is you're doing a DDoS, then the application switches to a DR, and then you attack the less defended. Maybe it's not up to date. Maybe it's not fully patched like the production site. So that's again another reason. And last but not least, LOLs. Sometimes people are bored, and that's what bored people do. We've seen attacks, for example, after soccer games, they're attacking the rival city or the rival team or the rival country, depending what's the game, and such attacks on pop stars, rock stars, etc., just because you don't like the same genre of music. So that's another reason. So now what I was thinking of doing is to simulate an attack, okay, a volumetric attack, and let's see what we're going to do. It's a simple demonstration, right? It's a very simple demonstration even, and I think that I hope that it gets you to think also in other ways about playing with network protocols as well, and see how fun it is if you're not already doing it. So when we're starting to do the simulation of the volumetric attack, let's just do a quick recap. Everybody knows the 7 layers OSI, right? Okay, so let's just do it quick. Let's not deal with the physical layer and layer 2 as well, as we're talking about attacks over the internet. So we're starting at layer 3. Layer 3 is the IP protocol. Basically, it's the routing where you want to be going, like the address. I want to go to Novi Sad. Okay, I want to go to IP 8.8.8.8. So this is the IP. On top of IP, we have layer 4, which is transport protocol. Okay. Cool. So what's your favorite transport protocol? UDP? Okay. There's no correct answer. It's a favorite protocol. So anyway, so there's mostly TCP and UDP. Like we mentioned, TCP has the 3-way handshake. So we will not use TCP for the demonstration, but we will use UDP. What is the most common application layer protocol on top of UDP? No. No? DNS. Okay. So DNS, and we'll use DNS. It's pretty classic. So this is the layer 7 protocol that we're going to be using. So in order to do that and to demonstrate some volumetric attacks, and now I know that when running this, things will go wrong, so bear with me. Always with demos, this problem. So let's see what we're going to do. Tool introduction, Wireshark. As simple as possible, Wireshark. We're going to use Wireshark in order to see the packets coming in. HPing3. HPing3 is a very simple command line tool that you can use in order to send packets. Scapy. Scapy, which is a Python library for which you can do a lot of cool network stuff. And what we're going to use it for today is the coolest of them all, which is to create your own packets. You can control pretty much anything you want when you're crafting packets using Scapy. You can send illegal packets with illegal checksums. You can do whatever, pretty much whatever you want. You can say you're sending 4 records, but really include 5. You can do a lot of it. You can use it for fuzzing. You can do it for many other reasons, and I think that we should all use it for one thing or another. And let's have a quick glance of what we're going to do. So first of all, this is SYN Flood. SYN Flood is basically sending a TCP SYN packet saying, hi, the destination, which will go through IP. So hi 1.1.1.1, I'm 2.2.2.2, even though I'm not, okay? So we can't complete the 3-way handshake, but let's handshake. And the machine, on the other hand, will have to keep state of disconnection, and it will send sure 2.2.2.2. Let's handshake, and it's sending the response to someone else. Okay, but we don't care about it, or we may even care about it, so we can change the attack. But that's basically a SYN Flood. Let's look at a simple SYN Flood. So let's run Kali. Okay, so first of all, let's have a victim. And who's better at being a victim than Windows? Let's have a Windows victim machine. And okay, so this is the Windows victim. Now these machines are on a NAT, but of course, since it's over IP, it can also be external IPs. It's all the same. So this machine is 10.0.2.15, right? And this machine is 10.0.2.6, okay? So we can send a simple, let's open a Wireshark on the other side. And we're opening that on our Windows machine. And so we can send basically pings to 10.0.2.15, right? So we can send these and they will arrive. Unlike Windows, it's not ICMP pings, it's TCP pings. So let's stop it. So we can send that, but we can also send, say that we want to send SYN specifically, okay? And we want to send them real fast, okay? So we do flood, okay? And then we're sending the lots of SYN requests flowing into our server, okay? Now, of course, if we look at here in the task manager, so we see that we're sending quite a bit of traffic. Now, of course, if we have a botnet, we can send, send it in the multiplication of the bots that we own. Let's stop this attack. Now, what you've seen is very is not spoofing the IP source, right? I'm sending it from my source IP. So you can also, I think it's run source, but maybe I'm wrong. Okay, run source, and then when I send this, let's see if Wireshark is still up. And when I do this, it will send it from random sources. Now, of course, okay, so it sends it from random sources, which is both more useful for filling up the table for our victim, and also more useful as in not sending our IP to the victim. Now, this is of course just a sample with hping 3, and of course with many other tools, and basically any programming language, we can send tons of these packets. We can send different TCP flags, for example, send synax, send resets, send other flags, some of them to trick mitigation, DDoS mitigation appliances, and such. So you're getting the idea. This is hping, and this is what it does, sends lots of packets. So we can also send an ACK Flood, which is basically instead of -s, you're doing -a, and it sends the flag of ACK or synac. Again, mostly these games are used because in order to fool mitigation services of our victims. So, and we can do again a reflected attack by sending SYN packets and saying, I'm the victim. I'm sending you a SYN, and then all the victims, all the machines that I'm contacting will send back a synac to the real victim, which will get lots of packets from lots of different sources. So far, so good. Okay, so this is just sending packets. So let's look at another example. I think this will be even nicer. Let's look at the DNS amplification example. Okay, good. Are you drinking them yourself, or you're distributing it? No. Okay.
Does anyone want a shot?
Come on. Okay, good. So, basically, with the DNS amplification, we spoke about it before, and what we're asking from the DNS server is any data, basically. In this example, and in most attacks, we will ask just give me anything you have on a domain, and then it will send all this reply to the victim. Now, the reason it's called amplified attacks is, I don't know.
Then you get the shot.
Okay, because I tricked you. Okay, this is a shot. This is like 5 shots in one.
That's a Serbian shot.
Serbia.
That's a Serbian shot. Okay, I'll try not to trick you anymore. Okay, so basically, okay. So basically, in this type of attack, we're asking for a lot of data. So we're leveraging our power. We can send 40 bytes or slightly more, and the attacker, the victim, gets 400. So if we have a 1 gigabit connection, we can now have a 10 gigabit attack power. So let's see how we do that. Okay. And this is, by the way, this is just a table I took from a NIST website, or from the US CERT site, sorry, showing different factors of the multiplication between sending the traffic and receiving the traffic, what you send and what the victim gets. Okay? So let's run one of these attacks. Okay? And for that, we will have another virtual machine, which is Coop Bank. Okay, it's just a victim machine. It's just a DNS for this example, at least. It's just a DNS. It runs bind on it. Bind is the common Linux DNS. And bind, the way it works, it's very simple to work. This is not the scope, but we can define DNS records in it, and it replies with the DNS information. So if we have this, so this is the DNS record for coopbank.com. It has a bunch of, I wanted to say bunch of shit. It has a bunch of records in it. So the name server, the A record, the text record, the MX, of course. So just a typical DNS record, which we're going to use. Another thing we're going to need is the IP of our DNS server. Now, this DNS server, and let's not get into a DNS recursion here, but this DNS server, the one that we're attacking, doesn't necessarily need to be the name server for that domain, because it can get all this information recursively. So there we have it, and our IP is 10.0.2.4. So now let's do the attack. First of all, let's clear Wireshark, and let's only look at traffic we have from 2. Was it 4 or 6? 4? 4 was the DNS server, or 4? Was it 4? Yeah. Okay. So we're looking for traffic coming from the DNS server. Now let's start the attack, and in order to do so, let's run Scapy. And now Scapy can either run as a standalone, or it can run as a module in Python. So because it's in Python, it's multi-platform. It can run on Linux. It can run on Mac, Windows. For Mac, it needs a little pushing to get it to work, but at least for me, it took some pushing, but eventually it worked. Okay, so we're going to define the packet that we're going to send. So let's start with IP. So we're just creating the object. IP is the IP. Let's call UDP as UDP. And we're also going to need DNS as the DNS. And another structure we're going to need is the DNS query. DNS QR. Okay. So now we have the object. Now it's very easy to play with Scapy, even if you haven't touched it in a long time. You can just use display. So display shows all the properties that you can set for the object. So yeah. It doesn't? So I highlighted them. So now it shows. Okay. Okay. So IP version 4. Of course, we can send IPv6 packets in it. And what we want to change is, of course, the destination, because we want it to reach which server? The Windows or the Linux? The Linux, right? The DNS server. So we want it to reach 10.0.2.4. Right. Now, once we do that, it automatically sets the source IP to our IP, just to make life easier. Okay. So that's about it, about the IP. Of course, we can play with it. In other projects, we can play with it. Then after IP, we have UDP. Now, UDP comes by default with DNS. Okay, so the source port and destination port by default, it's 53 DNS port. So we don't need to touch UDP. Let's jump to the DNS QR. DNS QR, we need to set the queue name, which is the domain we are querying about. So let's do that, coopbank.com. And the queue type, which is what type of information are we looking for? MX records, A records, AAA records. So we're setting it to 255, which is any. Okay? So that's it. We configured the DNS query record. And now let's set up the DNS. So with the DNS, what we want to do it is, first of all, we want to set it to, well, in this case, we don't need to, but still best practice. Recursive desired, meaning that we want this, if the server we are asking doesn't have the information, we want it to go to start recursion and get the information for us. Okay? And what are we missing? DNS QD count, which is query desired count. So let's set it to 1 because we sent one query. Now for different tests, we can like play with this, send 4 requests, and in the DNS put just 1 or vice versa. We can do lots of cool things with Scapy because basically we can set everything. And let's set the QD. QD is basically an object of type DNS query. So we want it to be the DNS QR. Okay, so now I have the feeling that I forgot something, but let's see if it still works. So let's do SR1, which sends the request of IP/UDP/DNS, and we have an error. Okay. Oh, it's not me. It's the Rakia. Okay, so, okay. Now we send the packet, and this is what we got, formatted in XML, sort of XML. It's the response. We can see here, I will highlight everything. So we can see we're getting the NS records, we're getting the A records, we're getting the, what else do we have here? Well, we're getting everything that we have about this, the TXT record. So we're getting everything, okay? Now, this attack is still not reflected, right? Because we're getting the data instead of our victim. So what do we need to change in order for the victim to get the attack? The source IP, right. So IP.source equals 10.0.2. What was the Windows? 15, I think. I'm not sure. Worst case, someone here will get the packet. Okay, so when we're sending this, if I will run again SR1, I will have a problem, a slight problem, that the Scapy is now waiting for more packets because I used SR1. So what I can do is use send. Send just sends it asynchronously and doesn't wait for a response. So when I'm doing send, it sends one packet. And now in Wireshark, let's clear it, but we've seen that it got the packet. In Wireshark, it got the packet, okay? Now, this is just an example, of course, but the length here is 402 bytes of of what we got. Then actually, by the way, because of Windows, it also sent an ICMP of destination unreachable because the port was unreachable because we don't have a DNS waiting on port 53 to listen for this. So basically, let's use Python's built-in length function to see how long is the packet that we're sending. Okay. So the packet we're sending is 58 bytes, and the packet we are getting is 402, not including the ICMP, which is another 430 to our outbound traffic. But that means that basically 58 divide by 402, that means that the amplification factor is about 6 times, okay? Now it all depends on the amount of DNS records we have, but that's the amplification factor that we have here, about 1 to 6. So this is how it works. We can also, we can also put it in a Python script. Oh, we're still in Scapy. We can put it in a Python script. Because of time limitations, let me just show you a small test here. But basically, because it's also a Python module, we can use it in Python. So this thing does the same. It does exactly the same as we've done here, command line. But then afterwards, it just runs a loop, sending 100,000 packets to our victim. So imagine also not necessarily about DDoS, also about other things. You can use this mainly for fuzzing and other things as well. I want to show you also how this type of attack looks like on different controls. So I built a sort of a demonstration dashboard to show different types of attacks. Okay. Now let's take a quick look at what we have here, so we can just demonstrate what happens in the receiver's end of this attack. So we have here in the top left corner, we have the edge router in the inbound router in the entrance to the organization network, and it has CPU monitoring on it. And it has the bandwidth and packets per second monitor for the edge router. Okay. We also have the firewall, and the firewall has the CPU monitoring, then the blocked versus passed monitoring, and we also have monitoring of the outbound traffic. And here we have just a sample. High-level sample of, we have a web server and a database server. So the web server, we have CPU, RAM, storage, and requests per second. And we also have the amount of sessions that are currently running on our website. And for the database, we have the CPU, the memory, the storage, and the network transfer, and the amount of connections on the database. And in here, just for fun, we have a chat window. It's not just for fun, it's because a lot of times we're getting the information about DDoS attacks not from the actual network controls, but from our clients, whether they're inside the organization or outside. So let's go to attacks. let's do a DNS amplification attack, okay? So, when we're doing a DNS amplification attack, and of course, the times varies, okay? It may take 5 seconds, it may take 5 minutes, but eventually what we have here is, first of all, a lot of times you're getting tickets, you're getting support tickets, like we have clients who can't access the website or any other web infrastructure. And then the edge router's CPU goes up because it needs to handle more traffic, but not by a lot. Not like if it has to handle a lot of packets per second. This is more of a bandwidth issue, but it doesn't need to take care of that many packets. So the CPU stays about the same. Packets per second stays about the same. The firewall starts working harder and starts blocking more and more illegal packets because no one is expecting those DNS requests coming at port 443 of our website, so it blocks them, but it still works harder. And the traffic out continues the same. The web server and database servers are pretty much the same. We may get a call from our ISP saying, hey, you're using a lot of more traffic, maybe you want to upgrade because you're selling more or you've started a campaign. And the web server starts to get less traffic. So if we're monitoring this, we're seeing an alert, not that it has 100% CPU, that it has less than usual CPU. And now basically with DNS amplification, in most cases what will happen after a while is a null route, meaning that your ISP will cut you down or your bandwidth will simply be full and that's it. And then your boss says, can you please step into my office for a second? So that's game over. So that's the DNS amplification like it looks in the control of the organization. Of course, everything varies. I would like to show another attack just to show the difference. I mentioned high PPS attacks before. So those are attacks again in the network level, but we're sending a lot of SYN packets. And so it's different, smaller packets, so the bandwidth, as you can see, it goes up but moderately, not by a lot, and the packets per second rises more. This is of course a demo dashboard, so you don't see all the fluctuations that you will see in the normal network, which will confuse you of course. And then starting getting complaints. And our firewall and edge router are now in a high PPS attack. They're now competing on who breaks first, depending on the model, depending on the configuration. For example, if we have packet inspection enabled, on one end it's good, it's trade-offs, right? On one end it's good because it's good to detect certain types of attacks. But on the other hand, because we have packet inspection, it will take more CPU per traffic. So again, we will see more and more blocked responses, and then probably the firewall will crash or the edge router will crash. So these two attacks, although very similar in terms of attack, you're sending traffic. You're either sending small packets of probably SYN, but not necessarily, or you're sending large packets using reflective amplification, but thank you. But I will drink water. But on the control of the organization, they will look totally different, and I think that this is one of the challenges with DDoS attacks, that they look totally different types of attacks. I will just give another example of a DB flood, a database flood attack, like the one I mentioned before. And this one doesn't show anything on the network controls. Why? Because the traffic is meaningless. It's marginal. It's not a lot of traffic coming in. But on the other hand, the web server starts working hard, and the database server's memory starts working very hard, and CPU also. And again, this really depends on the type of database that you're using, and the configuration. So if you set up lots of memory for the for your database, it may reflect more on CPU. If you put less memory, it may take more and more memory. It all depends on the configuration and also on what the actual database attack is doing. Does it query information that's hard to query? Does it do lots of insert updates, etc.? So again, these attacks are very different in how they portray in our systems. Okay, so getting back to, I see that this is 3:40, so we have until 3:45 or something. Okay, so I think that I planned more content, but you know how it is. Usually it's more time because it's sort of a workshop. So before questions, I would like to thank you all, and I practiced on this. So. Mnogo vam hvala. Oh, shit. Okay, and again, questions would be lovely. And of course, I can answer questions, you know, in the corridor as well. But any questions would be lovely.
With mic.
With mic, whichever you want. What you do when you're under attack? Yeah. Well, this is first of all, it's I know that it's always the thing with information security, and also when I was in offensive security working as a penetration tester and head of offensive security, we always had clients coming to us when they were under attack. And of course, the simple solution would be plan ahead and don't get yourself in a position where you don't know what to do now because you're attacked. Now, it depends on the type of attack, but because attacks are versatile, of course, my initial instinct would be call in capsula, not me, but the sales guys, which will solve your problem. But seriously, because DDoS attacks are sometimes or most times, using bandwidth that is more than the bandwidth you have, mostly the solution is to route your traffic through the cloud, either always or just when you're under attack. So basically what you're doing is, again, it differs between services, but you route your IP or subnet is routed through the cloud provider, like us, of course, and then it goes, let's say, through a GRE tunnel to your infrastructure, and it gets scrubbed in the cloud. Now there are also a lot of solutions in the organization, but if you will get saturated, if your bandwidth will get saturated, then you can have the best appliance that will actually know, and this is not the situation, but it will actually know for each packet in real time what's an attack and what's not. But since you're limited in your bandwidth, then you will still be down. Because it's very easy to get a lot of bandwidth to get you down, unless you're Google or Microsoft or Amazon, where you have bandwidth to spare. You know, you have more bandwidth than the attacker, so this is not a problem for you. So most, if not all, DDoS mitigation services in the world are using cloud, either only cloud or a hybrid solution, meaning that part of the attack is mitigated in the cloud and part of it is in the organization. Hope that helps. Okay. Cool.
I have a question.
Okay.
Can I ask you? So,
Yes.
do you perhaps read about bug bounties and such things? Because I remember vulnerability through the think it's a nodes functionality.
Okay.
Sending the parameter to the picture link hosted on some website or the PDF file.
Okay.
So it uses the actual Facebook's servers and bandwidth attack slots.
So again, this is more or less the same. And I've seen a POC lately. I'm sorry, but I don't remember who's the researcher who did the demonstration. But same with Google, because Google has open redirect, and they don't see it as a security vulnerability. So if you're sending clients, you can send, for example, XHR requests in a web page to a client, then it goes to Google, and then Google redirects it to the web page, or you can use some of their services and use these services as an attack. There's also, for example, the Google Translate, where you can, check payloads without when actually Google is the one sending the request. So yeah, sure. If there is a service that allows you to send lots of traffic through it, then and of course, let's say that people will be reluctant in blocking Google to their application or blocking Facebook, then that may be a good idea. I don't know if it qualifies for their bug bounty. We'll have to ask them, but.
Great talk. Where can I play with the dashboard?
Where can you what?
Play with the dashboard.
With what dashboard?
Well, the one you saw, the one you.
The one.
Screen.
Well, first of all, the dashboards are in my machine. So if you can give you my password and you can play with it, okay? And well, because it's still I'm working in a company. Still, I'm hoping that after this talk with the Rocky idea, which I didn't ask anyone about, I will still be working in my company. But anyway. So because it's a company, so it has to clear first. It's still, like a midway project. But once we will, I will be happy, to connect with you. And once it's publicly available for playing with, then I can send you the link.
Hi, I have a question about DDoS. For example, you gave the example when I say something like, as if I said to everyone in this room, "Hi, I'm Ben, I want to handshake with you," and everyone sends acknowledge packet to you back. How traceable is that to me as an attacker?
It's not. In the internet, in a LAN it may be easier, of course, but in the internet, because of the way the internet works, it's basically, I'm not saying NSA impossible, but it's virtually impossible to detect you. First of all, when you're attacking someone, you will probably, at least in the beginning, use one of the DDoS for hire services. So, first of all, that's the first layer of separation. And then they will send DNS request, for example, to the server in order to create a DNS amplification attack. And good, you're alert. Okay. And then this server replies to the source IP that he has. So and of course, because DNS requests are so common, and he will only have the last hope because of the way BGP works. Basically, if he tries to trace route, for example, he will try to trace route to the victim, not to you. Now, I'm not saying that you can't be caught, but all of the attackers who were caught doing that were caught for other reasons. The two Israeli guys who got arrested, they also weren't caught for the attack itself. They were caught because they had a vulnerability in their web application, and someone use that in order to expose them. So, and that's usually where it goes. Someone either traces the money or something like that, or someone brags, or someone snitches. It's not that trivial to find the source of DDoS attacks.
Thank you.
But don't do a DDoS attack just because it's
Fun. Okay, thank you.
it's hard to detect.
Hello, great presentation. Congratulations. I would like to ask you about the DB attacks.
The what? NTP?
Database attacks that you mentioned.
Okay.
The database
Yeah.
attacks. Is it actually the configuration of the database or the application that is written behind?
Well, it can be both. Usually it's the application. When I was back in the days, in the good old days where I used to hack sites for a living, be a penetration tester. If you think, before that I was a developer, so if you think like a developer when you're accessing database, accessing database, let's say for an e-commerce website, is enough of a challenge as is. And thinking of not what you're trying to work for the benefit of the majority of your clients. So you're setting the indexes that way. You can't index all the columns in all the tables, and you have to do trade-offs. And usually it's in the application layer. Some of the times it may be a process. So you may, let's recall to Dima's talk from the first day, you may use, for example, headless browsers in order to complete a full cycle of some sort of a process that will cause a big strain of the data on the application. I can remember, for example, there was an application, a mapping application, that got as a parameter, it was sort of get image dot whatever, and then as a parameter, it got the size of the image that you want to do. And they used something like, I don't know, ASP, JPEG, ImageMagick or whatever in order to resize it. But it wasn't limited. So you could set it to 5 gigabytes. And when you do that, it consumes tons of memory. This is not database, of course. This is layer 7 attack, not database related, but I think it also answers your question. When doing a sophisticated web application, unfortunately, a lot of times the security comes in only when everything is finished and you're just doing a PT to get it published in the best case scenario. In the worst case scenario, you don't even do that. So, and when you do the penetration testing, usually DDoS is neglected, DOS is neglected. The penetration testers are always looking for the SQL injection, and that's good. That's what I was looking for as well. SQL injections, remote code executions, path traversals, etc., all the sexy stuff that you can get actual data from the system. Like measuring latencies between requests so you can prove that someone with one single machine can knock off your website. That's something that most penetration testers don't do. It's usually even outside of the scope of the project. So usually it's the application, not the configuration, because IT, and I'm saying this carefully, but IT and DevOps usually, well, I wouldn't say they usually follow best practices because they don't, but I would say that most of it is application still. Come on, work with me. I will give the bottle to the next question. I saw that this technique was done here. I'm copycatting. Okay, yes, you have a question.
Can you say mnogo hvala again, but better?
Mnogo vam hvala? No. Well, pour me a drink and then I can say it in Serbian because.
I did it.
Oh, yeah.
Wait, we need to drink it like this. So
Oh, okay.
Take it in the right hand.
Mnogo vam hvala.